Okay, so let's have a look at this sketch. So we're sketching 3 times 2 to the power x plus 2. So remember, this is just the way we're writing it mathematically, with our f of f maps onto r, which is a real number plane, maps onto r. So that's just our fancy way of writing it. Now, if I was to just do 2 of x, then this is what my form would be. So this is a basic shape of our exponential functions, okay, so the graph of them. Just like before, this 3 is our dilation. This plus 2 moves the whole graph up. So imagine this, if that was our asymptote along there, and it goes up. Oh, my thing's disappeared. My axis has disappeared. Quickly draw that in. There we go. Okay, so that was a bit strange. Anyway, so we're back here. So there's my axis as it's gone up to. Rightio, so that graph goes the same. So we've got our asymptote here, y equals 2. So there's our asymptote. Remember, it doesn't touch it, it goes to there. We need to find our y-intercept. So y-intercept is when x equals 0, because we know 1, 2, 3, that's our x value, minus 1, minus 2, etc. Right on here is when x equals 0. So x equals 0. If I sub x equals 0 into this equation, so I get 3 times 2 instead of x to the power 0, plus 2. So anything to the power 0 equals 1. So I end up with 3 times 1 plus 2. 3 times 1 is 3, plus 2 is 5. So that's how I get that value up there. So just subbing in the 0 into that value just up there, and anything to the power 0 gives me 1. So I've got all of that. I've got my asymptote, I've got my y-intercept. Now I have to find my range, and my range, remember, is our y value. So that's this value up. So it doesn't hit 2, but it's everything greater than 2. So it's not an equals 2 because it doesn't touch the line here. And all we can write it as 2 to infinity, like that. Okay, so that's that one. And then if we just go to the next page, we've got 5c that we have to draw. So the function f maps onto the real number plane, maps onto r. Then we've got minus 3 to the power x minus 2. So we know our basic function shape goes like that. But this minus will flip it across the axis. So instead of going like that way, it's going to go down that way. This negative 2 moves the whole graph down. So we've got our asymptote at minus 2. Oops, I should have put a y in there. Okay, so we've got y equals minus 2. Now, where are we up to? Our y-intercept. Our y-intercept occurs when x equals 0. So we've got minus 3 to the power 0 equals 2. So this 0 belongs to that 3. So 3 to the power 0 was 1. So we've still got that negative out the front. Okay, it's not in a brackets, remember? So it's just belongs to that one. The minus stays out the front. So 3 to the power 0 is 1, minus 1 minus 2 gives us minus 3. Okay, so, and our range is going to be everything from this asymptote downwards. So less than or equal to negative 2 or negative 2 to, negative infinity. So actually I should write that the other way around, shouldn't I? So it should be negative infinity to negative 2. Okay. There we go. So I'll leave that to you. Hopefully that helps.